you're probably interacting with large language models or LLMs every single day, maybe without even realizing it.
That's right.
Maybe you're asking one for a quick recipe or, a summary of some complex topic, even a catchy slogan perhaps. But when you get an answer, how do you know if you're truly getting the, quote, best one? And what if best isn't just about accuracy or how, well, eloquently it's written?
Well, that's exactly what we're digging into today. We're doing a deep dive into the fascinating and actually surprisingly complex world of LLM evaluation.
Right.
And we'll be looking at a really interesting new research paper that introduces something called the Generative Energy Arena, or GEA.
Okay, GEA.
Okay.
So our mission today is to unpack the different ways we try to measure how good these models actually are.
Yeah, and highlight the big challenges in doing that.
Exactly. And then explore this really surprising factor that apparently dramatically changes how people perceive and prefer LLMs when they know about it.
Which is their energy consumption.
Energy consumption. It sounds like a shortcut to understanding not just performance, but also their kind of hidden environmental footprint.
Precisely.
So let's unpack this then. LLMs are everywhere doing all sorts of things, but figuring out which one is best or even just how well they really perform. It sounds incredibly complicated. Why is that? What makes it so tough?
Yeah, it really does sound like it should be straightforward, but it's actually quite tricky. The paper lays out why, starting with what seems like the easiest method, automated benchmarks.
Okay, like standardized tests for AIs,
Yeah.
multiple choice, that kind of thing.
Exactly. They can run them at scale, testing tens of thousands of questions, which is great for efficiency.
There's always a but.
There is. They often have a pretty poor correlation with how humans would actually rate the answers. Plus, they can suffer from the LLM's own biases.
Biases in the test.
Or biases in how the LLM answers, yeah. And sometimes, the test questions themselves have actually been seen by the model during training.
So it's like they studied the answer key.
Kind of. It skews the results. And actually, LLMs are starting to just ace these benchmarks. They're saturating them, getting most answers right.
So if they're acing the tests, are the tests still useful? Does that mean we're hitting a wall there, trying to measure just pure accuracy?
That's a really key challenge. So another approach people try is using one LLM to evaluate other LLMs.
Okay, AI judging AI.
Right. And that also lets you test at scale, which is a big plus. But interestingly, LLMs can bring their own biases when they're acting as judges.
How so? Like favoring answers similar to their own style?
Yeah, maybe favoring certain phrasing, certain structures that they themselves are prone to generate. And crucially, their judgments don't always line up perfectly with what humans prefer.
It's like asking a student to grade another student's paper, maybe. A bit subjective.
That's a good analogy. Then, of course, there's the obvious solution. Human evaluation.
Right. Get people to actually read the answers. That seems like the gold standard.
It often is seen that way, yeah, because it directly captures what users actually like. But it faces huge scalability problems.
Just too slow and expensive.
Totally. New LLMs are popping up, almost weekly now, getting thousands of people to rate thousands of answers for every new model. It's incredibly time-consuming and expensive.
Right. So human evaluation is ideal in theory, but just a logistical nightmare with how fast AI is moving.
Precisely. So that brings us to the last main method, public arenas.
Like the chatbot arena people talk about.
Exactly, like the popular LM arena. Any user can go on, ask a question, and then they rank the answers from two unknown model.
Blind testing.
Yep. And the results get crunched to create a ranking, kind of like how chess players are ranked using the ELO system.
Okay, that sounds pretty good. Crowdsourced human preference.
It is widely used, and it is based on human preferences. But these arenas also have limitations. The questions aren't controlled. People asking can be anyone from experts to casual users. The evaluator profiles vary a lot.
And I guess there's even potential for people trying to game the system.
There is, yeah. Potential for manipulation of the rankings exists.
Okay, so we've talked about evaluating the quality of the output, accuracy, preference. But you mentioned another angle, a hidden cost. What's this dimension that's often overlooked?
Right, the overlooked aspect, and it's a really big one. The massive energy consumption of these LLMs.
Okay, we hear about training energy. That takes tons of power.
It does. Training requires immense processing power. It's a well-known energy hog. But this paper also focuses on inference.
Inference. That's when the model is actually being used, right? Answering questions.
Exactly. When millions of people are using them every second, responding in real time, that also consumes a significant amount of energy. And there are big efforts now to understand and, optimize this energy use during inference.
So it's like a running cost, an ongoing environmental footprint with every single query we make. Why is understanding this inference energy suddenly so critical?
Well, it raises a really important question. If you, as a user, actually knew how much energy different models were using, would that change your choice? Would it influence how you compare LLMs? It's vital for understanding what users truly value. Is it just the best possible answer regardless of cost? Or is there a trade-off people are willing to make for efficiency?
Performance versus cost. But the cost here is energy.
Precisely. And we need to know if people actually factor that in or would factor it in if they knew.
So to get at this exact question, the researchers built this thing you mentioned earlier, the Generative Energy Arena, or GEA.
Yeah.
How did they design it to specifically test the impact of knowing about energy use?
Right. The GEA is basically an LLM arena like the others, but it uniquely folds in information about energy consumption right into the evaluation. They had to be pretty clever about it.
How so?
Well, first, how do you even provide the energy info? The challenge is absolute energy numbers like watts or joules aren't public for most big proprietary models.
Right. Companies don't usually share that.
Exactly. And even for open source models, the energy used varies hugely depending on the hardware it's run on. So the GEA does something smart. It gives the information in relative terms.
Relative, meaning?
Meaning, when you compare two models side by side, it just tells you which one used more energy. Not the exact amount, just Model A used more energy than Model B.
Ah, okay. Simply. Less confusing than technical numbers.
Definitely simpler. And to make that comparison fair and clear, they only compared models of different sizes from the same family.
Like a big version and a small version of the same underlying model.
Exactly. Like, say, a standard GPT 4.1 versus a GPT 4.1 mini. The basic assumption, which is generally true, is that the bigger model in the family uses more energy. That simplicity is key for regular users who aren't, energy experts.
Okay, that makes sense for presenting the info. But how did they stop that energy information from immediately biasing people's initial judgment about the quality of the answer?
That's the other clever bit. They used a crucial two-step evaluation process.
Two-step?
Yeah. First, you ask your question, you get answers from two unknown models, Model A and Model B. You pick the best answer based only on quality. You don't know anything about energy yet.
Okay, standard comparison first.
Right. Then, step 2, if, and only if, you happen to pick the answer from the model that uses more energy.
Ah.
Then you get a follow-up question. It basically asks, okay, you preferred this answer, but knowing the other response used less energy, would you change your mind, even if it means potentially accepting a slight dip in quality?
I see. So they measure quality preference first, then see if energy info makes you reconsider. That really isolates the energy factor's impact.
Exactly. It's a neat design to measure the specific influence of energy awareness on your choice.
And how did they actually measure that influence?
Right.
Did they have specific metrics?
They did. They defined metrics, including one they called E. That's basically the fraction of times people did change their vote after learning about the energy difference.
Okay. The energy change rate, essentially.
Pretty much. And they also looked at the overall winning rates of the models, how often each model won before the energy info was revealed versus how often it won after people considered the energy factor.
Okay, so they built this clever arena. They had a way to measure the impact. What happened when they actually rolled it out to real users? What did they find?
So they deployed the GEA as part of a MOOC, a massive open online course at the Universidad Politécnica de Madrid.
Ah, using students.
Yeah, students were asked to evaluate answers to questions given in their assignments and also to 5 questions they came up with themselves. So a good chunk of the evaluations, they estimate at least 83% came from these students who likely had some background knowledge.
Okay, and how many evaluations did they get?
They evaluated 694 questions in total.
And what sort of questions were people asking? Was it all technical stuff?
No, it was a real mix. Some were creative, like invent a slogan for a product or write a short poem following a specific rule. Others were more informational, like explain the top parameter in LLM.
Okay, that's a technical one.
Right, that set and controls how random or focused the AI's output is. But they also had questions like, tell me about this specific town, or even give me a recipe using these ingredients I have. A pretty broad range.
Got it. So the big reveal, what were the results? Did the energy info matter?
It mattered a lot. The results showed a really significant shift in votes once people were aware of the relative energy use. That change rate, L.
What you mentioned.
Yeah. It ranged between 41% and 52% across different model comparisons, but the average was around 46%.
46%. So nearly half the time when someone initially picked the higher energy model's answer, they switched their vote after learning about the energy cost.
Exactly. Nearly half of users changed their minds based just on that relative energy information. It strongly suggests that energy awareness really can be and maybe should be a core part of how we evaluate these things.
Wow. That's actually huge. It implies people are willing to make that trade-off you talked about. What about the overall winning rates?
Even more striking. So before the energy info, the initial preference between the bigger and smaller models from the same family was pretty close. On average, less than a 2% difference in how often each was initially chosen.
So roughly a 50-50 split based on quality alone, more or less?
Pretty much, yeah. But the winning rates after accounting for energy efficiency, they massively favored the smaller models.
How much?
Users ended up choosing the smaller, more energy-efficient model more than 75% of the time.
75%. So it went from nearly even to a landslide victory for the smaller models once energy was factored in.
A complete shift. Think about that. People were essentially saying 3/4 of the time, yeah, the smaller model's answer is good enough, especially given it uses less energy.
That really challenges the idea that bigger is always better, doesn't it?
Yeah.
We often chase the absolute top-performing model.
Without maybe realizing that the extra performance comes at a significant energy cost, and perhaps for many common tasks, that extra quality isn't perceived as worth it by users when they know the cost.
Did they see any difference between the model families? Like, was this true for GPT, Llama, Claude models they tested?
Interestingly, there were some nuances. They found initial preferences before energy info varied a bit. For instance, with Llama 3, the larger model was actually chosen a bit more often initially.
Oh.
Whereas for the GPT families they tested, the smaller models were slightly preferred even before the energy reveal.
Huh. Any idea why?
The paper doesn't speculate too much, could be down to the specific models or tasks. For the Claude family, the initial preference was less clear, more evenly split, but the overall trend after revealing energy info was consistent, a strong shift towards the smaller models across the board.
So what's the main takeaway here for you, the listener? What does this mean for everyday use?
Well, it really suggests that for maybe most of your day-to-day interactions with LLMs, asking for summaries, brainstorming ideas, getting quick facts, the extra cost and energy burned by those really huge, complex, supposedly top-tier models, well, it often doesn't provide a noticeable enough bump in quality to justify that energy use, especially once you're aware of it.
Smaller models are often, good enough?
It seems that way for a lot of common uses, more than sufficient and much more efficient.
Now, this sounds really compelling, but you mentioned it's based on one study. Are there limitations we should keep in mind?
Oh, absolutely. And the researchers are upfront about them. This is an initial step. For one, the number of questions, around 700, and the number of users, mainly students, was relatively small. Ideally, you'd want thousands.
Right. More data is always better.
Definitely. Also, the number of LLMs evaluated was limited, just models from 3 major families.
So not the whole universe of models out there.
No. And the analysis was only done in one language, Spanish. Plus, they didn't break down the results by the type of question. Okay. So, it's possible that for certain kinds of questions, maybe very complex, creative, or highly technical ones, that the extra power and energy cost of the larger models might actually be seen as worthwhile by users.
That's entirely possible. That needs more investigation. Maybe for writing intricate code or generating very nuanced long-form text, the bigger model's edge would be more valued, even considering the energy.
Okay, so caveats noted. But stepping back, even with those limitations, what's the bigger picture here? What are the implications?
Look, despite the limits, the findings are pretty powerful. They strongly suggest that energy information is a critical factor for human evaluation. It really should be part of the conversation, part of future evaluation methods.
Moving beyond just accuracy and fluency.
Yes. And it implies that maybe LLMs have hit a point where, for many common tasks, the smaller, more efficient versions are genuinely sufficient. The larger models might only add significant perceivable value for very specific, complex kinds of queries. We've taken quite a deep dive today, then, into this complex world of figuring out how good LLMs are. And we found how this clever new platform, the Generative Energy Arena, is showing us something quite surprising about human preference.
Yeah, it really turns out that when people are just made aware of the energy cost of these AI models, their choices can shift and shift dramatically, favoring smaller, leaner, greener versions for most things.
So it leaves us with a thought, doesn't it? What responsibility do you have as someone using these tools or maybe even developing them?
Right, to consider the environmental impact, especially now we have evidence that people are willing to prioritize efficiency when they know about it.
And what does this mean for the future of smart tech? Does smarter always have to mean bigger, more complex, more energy hungry?
Or could smarter actually mean more efficient, more sustainable? Maybe that's the direction things need to head, something to definitely mull over until our next deep dive.